Hello, welcome back. So we can start our first class of engineering mechanics with Introduction to Mechanics. Mechanics. Mechanics is a branch of physical science which deals with bodies in a state of rest as well as in a state of uniform motion under the action of force. So a body can resist any kind of force acting on the body. So, what all are the reactions that the body is able to exhibit under the action of a force, whether the body is in a rest or in a uniform motion? What all are those reactions? Throughout this mechanics, this will be the consideration. In many real world problems, we could able to apply this engineering mechanics principles for solving so many issues. Throughout this study, we could able to explain what all are those applications. Mechanics can be broadly classified into three: classical mechanics, relativistic mechanics, and quantum mechanics. Classical mechanics is also known as Newtonian mechanics. This is proposed by Sir Isaac Newton. Using this, the behavior of bodies under the action of any force is explained using Newton's laws of motion. Coming to the relativistic mechanics, which deals with the behavior of bodies which are able to move under higher velocities, that is, relatively equal to the velocity of light, dealing with those bodies. This is proposed by Albert Einstein. Then coming to the third branch, which is quantum mechanics, which is dealing with the intermolecular or interatomic distances of the body, which is dealing with the behavior of bodies under the action of any force by considering the interatomic or intermolecular relationships. This is also known as wave mechanics and is proposed by Schrodinger and Broglie. So coming to the engineering mechanics, this is our target of consideration. So engineering mechanics can be broadly classified into two according to the consideration of objects. If you are considering solids, then that can be mechanics of solids. If you are considering fluids, fluids are those materials which are able to flow. If you are considering fluids, then that comes under mechanics of fluids. So here in this chapter, we are considering solids only. Within solids also, there are two types of bodies: rigid bodies and deformable bodies. For a rigid body, if we are drawing a line and if we are drawing a line on that body and we are applying a force on that body, maybe that body moves from its original position to some other position. But that line which we had already made in that body will be parallel to the initial position for a rigid body. That means there will be no bodily changes occurs in rigid body. But that is not the case for deformable body. If we are drawing a line on a deformable body and we are applying any force on deformable body, after the moment, after its change in position, since the body itself is able to deform, that line won't be parallel to the initial position. That is deformable body mechanics. So for we civil engineering students, we already know that we have two subjects which is under considerations are engineering mechanics and strength of materials. So in engineering mechanics, we are throughout considering rigid bodies only. But for strength of materials, we will be considering deformable bodies. We will be considering elastic modulus, Poisson's ratio, all those terms. But here in engineering mechanics, we are assuming or we are considering all the objects as rigid bodies. That means those bodies will take some change in their position while force is acting on that body, but there will be no bodily changes occurs. So engineering mechanics deals with rigid body mechanics, which can be classified into two: statics and dynamics. If the rigid body is at rest, then that comes under statics. If the rigid body is in motion, that comes under dynamics. And also, if the moving body, while studying the characteristics of a moving body under the action of any force, if we are considering the cause of motion, then it comes under kinetics. If we are not considering the cause of motion or the force which is responsible for the motion, If you're not considering that, then that comes under kinematics. So here in engineering mechanics, we are dealing with statics, dynamics, kinetics, kinematics, and we are not considering mechanics of fluids as well as deformable body mechanics. So, so throughout this engineering mechanics, we are dealing with the classical mechanics only. That is, we are applying the principles of Newton's laws of motion to the real world issues, not the quantum mechanics, not the relativistic mechanics. So we are dealing with Newton's first law of motion, second law of motion, third law of motion, Newton's law of gravitation, principle of transmissibility, parallelogram law. In this video, we can discuss about all these laws as an introduction to the mechanics. So starting with Newton's first law of motion, which states that a body continues to be in a state of rest or of uniform motion unless it is compelled by an unbalanced external force. So for any body which is at rest, if there is no external forces acting on the body, there will be no, that body could not able to attain a motion. And also for a body which is in uniform motion, if an unbalanced external force is acting on the body, then the body can able to come into the rest. Unless an external force is acting on the body could not able to attain the state of rest or uniform motion. Say this figure, the subject is in rest. When an external force is acting, body starts moving. When an external reaction came into effect, body stops. So, Newton's first law of motion explains the term known as inertia. What do you mean by inertia? Inertia is the tendency of the body to continue to be in a state of rest or in a state of uniform motion. So, through this Newton's first law of motion, he introduced the term inertia. So, the next law is Newton's second law of motion. The rate of change of linear momentum is directly proportional to the force applied, and the change takes place in the direction of applied force. So, the Newton's second law of motion introduced the term linear momentum. Linear momentum is the product of mass and linear velocity. This is applied to the this is directly proportional to the force applied and which acts in the direction of force. How we can represent this is mathematically dp by dt is directly proportional to F. So, look into this figure. Here, a man is trying to apply force for moving a body of mass m at an acceleration a. If we are applying more force, then the acceleration will be more. And if we are increasing the mass, what will happen? We could not able to apply this much force, and the acceleration will be very, very less. So what you can infer from this, force is directly proportional to the acceleration, but is inversely proportional to mass. So through Newton's second law of motion, he introduced the term linear momentum, and also he introduced the equation F is equal to ma, which tells that force is directly proportional to the acceleration and inversely proportional to the mass of the object. Then coming to the Newton's third law of motion. For every action, there is an equal and opposite reaction. See this because the accelerating force of the bullet is the action. The recoiling force on the gun is the reaction. When we are hitting a plane, that will be the action. The reaction given by the plane back to the action of hitting will be the reaction. When a boy needs to jump into the land from a boat, his feet exert a force on the boat. That will be the action. The boat in return reacts a reaction. That will be the reaction. Here also, look into this balloon. Air goes down, which is the action. In effect, balloon will goes up, that is the reaction. And also, Newton's third law of motion is the working principle of walking. And also, for this law to be valid, all the forces, all the bodies should be in contact with each other. This law explains the idea of reaction of force. Newton's first law of motion explains the idea of inertia. Newton's second law of motion explains the idea of linear momentum. Newton's third law of motion explains the idea of reaction forces. Then coming to the next law, Newton's law of gravitation. So, if there are two bodies of mass m and small m separated by center to center distance r, then these bodies will experience a force of attraction between them, which is proportional to the product of their mass and inversely proportional to the square of the distance between them. So, what will be the mathematical equation? F is directly proportional to product of the mass m into m and inversely proportional to square of the distance between them, that is divided by r square. So, the proportionality constant is g. So, this g is known as universal gravitational constant. Its value is 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. And this force can be expressed as, see this figure, the mass is m1, this mass is m2, then the force will be m1 into m2 divided by r square. Okay, which is proposed by Newton. This law is considered as a universal law which can be applied to any bodies in the universe. Okay, now we can shift to the next law, that is principle of transmissibility of forces. It states that point of application of force can be changed along its line of action such that the effect remains unchanged. That means even if the body is same and the intensity of the force is same, while the force is applying anywhere through the line of action of force, that won't change the action. That won't change anything on the body. The body will be remain in the same position. Why? Because the same line of action, say the same intensity of force will not create additional impact on the body. See this figure, same intensity of force, same line of action. Nothing will be changed. Here also, same line of action, anywhere the point will be acting. So using this principle of transmissibility of force, in the coming sections, we will be discussing about the free body diagram, reaction forces. All these things are solved by the principle of transmissibility of forces. We are doing lot of analysis using this principle of transmissibility of forces throughout this engineering mechanics subject. But this can be applied to rigid bodies only. What happened to deformable bodies? For deformable bodies, while a force acts on that body, the body itself does some deformations. Body itself undergoing some deformations. Then this line of action of force will be having no priority or no importance in that bodies. So this principle of transmissibility of forces can be applied to rigid bodies only. Thank God we are discussing about rigid bodies only in this engineering mechanics. So the state of rest or motion of a body will be unaltered if the force acting on the body is replaced by another force of equal magnitude acting in same line of action. Okay. If intensity is not changing and if the line of action is same, then any kind of forces is acting, there will be no change in the body. That is principle of transmissibility of forces. Okay, then coming to the parallelogram law of force. If there are two concurrent forces acting simultaneously at a point in a body represented by two adjacent sides of a parallelogram denoted in magnitude and direction, then the resultant is given by the diagonal passing through the point of intersection of these two forces denoted in magnitude and direction. So we can explain this with the help of a figure. So the two coplanar, this forces for applying parallelogram law force, the forces should be coplanar also. What do you mean by coplanar force? What do you mean by concurrent force? For a coplanar force, the forces should be in same plane. What do you mean by concurrent force? The forces should acting on same point. So for a coplanar concurrent force, two forces. In parallelogram law forces, we are considering about two forces which are coplanar as well as concurrent. Let the forces be P and Q, which can be represented as adjacent sides of a parallelogram. Let the parallelogram be OACB. Then the adjacent sides will be represented as P and Q. What do you mean by taken in same order? Taken in same order means from this O, from this origin point, force is moving away. If this P is moving away, this Q also moving away. That is the meaning of taken in order, which means the exact meaning of what you mean by taken in order means denoted in magnitude and direction, which means denoted in magnitude and direction. Denoted in magnitude and direction means in same magnitude and same direction. Not in same magnitude, but in same direction. So P is also acting away from the origin, Q is also acting away from the origin. Then the resultant will be the diagonal, which also acts away from the origin. There will be a result. There will be a diagonal for this parallelogram. That resultant will represent. That diagonal will represent the resultant of this P and Q. So the angle between these two forces is, let it be theta, and the angle of resultant, direction of resultant with respect to the horizontal is alpha. Then resultant can be expressed as square root of p square plus q square plus 2pq cos theta. Then the direction of resultant tan alpha can be represented as q sin theta by p plus q cos theta. This can be inferred from a derivation. Like no need to explain what will be the derivation. Like we can consider OCD as a right angled triangle. Then R will be the hypotenuse. So for getting the hypotenuse, we have this P plus Q cos theta. If this side is Q, this side will also be Q, and this is the angle theta. Then if this is Q, then this will be Q cos theta. This whole side will be P plus Q cos theta, and this altitude is Q sin theta. This side is Q, this angle is theta, then this will be Q sin theta. If altitude is there, base is there, we can find resultant as hypotenuse, root of p square plus q square plus 2pq cos theta. How can we find the direction? Similar way, tan alpha will be equal to q sin theta by p plus q cos theta. Simple derivations. Then from this parallelogram law of forces, for the resultant R to be maximum, the angle of inclination between the two forces should be zero by being collinear forces having same line of action acting in same direction. If the two forces P and Q are acting in same line, if two forces are acting in same line, then that forces can be called as collinear force. And also if they are in same direction also, then the angle between those two forces will be zero. Okay, when the angle between two forces is zero, the resultant will be maximum. We can explain it how, um, and also we can explain when the resultant will be the minimum. If two forces are acting, if two forces is collinear and they are in same line of action but acting in opposite direction, then the angle between those two forces is 180 degree. This is not 1800, this is 180 degree. So cos theta is equal to cos 180 is equal to minus 1. Okay. Then what will be the R maximum? P square plus Q square plus. For R maximum, we already told that theta should be 0. What happened? Theta should be 0. If theta is 0, then cos theta will be 1. Then P square plus Q square plus 2pq. That's why it is telling like R maximum. For getting R maximum, theta should be 0. For getting R minimum, theta should be 180 degree. Then this equation will be p square plus q square plus 2pq. R minimum will be p square plus q square minus 2pq. So R maximum will be p plus q, R minimum will be p minus q. If two forces p and q are represented as adjacent sides of a parallelogram, then the resultant will be the diagonal. For that resultant to be maximum, the Maximum resultant will be the summation of those forces, and the minimum resultant will be the difference between those two forces. There were lot of other inference also we can made from this parallelogram law of forces, but for time being I'm stopping this. We can jumping into another law. This is triangle law of forces. Two forces represented in magnitude and direction by the two adjacent sides of a triangle taken in order as both either clockwise direction or anti-clockwise direction will be having resultant as other side in opposite order to the two forces. So if two forces are represented in magnitude and direction as a two adjacent sides of a triangle, then the third side represented in opposite direction will be the resultant. So what do you mean by taken in order? Taken in order means either both clockwise or both anti-clockwise. Then the resultant will be, if the two forces are represented as clockwise, then the resultant will be anti-clockwise. Resultant will be the third side and is represented in anti-clockwise direction. If the two forces are represented as anti-clockwise, then the third force will be represented in clockwise. Here in this figure, let the forces be P and Q. This P and Q are represented as two adjacent sides of a triangle taken in order. That is, P is also in anticlockwise direction. As per this figure, P is in anticlockwise direction, Q is also in anticlockwise direction. Then the resultant, what will be the resultant? P plus Q. The resultant will be the third side which is acting in opposite direction. That is, P and Q are acting in anticlockwise direction. Then the resultant, which is the third side, which acts in clockwise direction. So this is triangle law of forces. Now coming to polygon law of forces, which is similar to the triangle law of forces. If a number of forces acting simultaneously on a body can be represented in magnitude and direction by the sides of a polygon taken in order, then the resultant will be the last side taken in opposite order. For the triangle law of forces, we are dealing with triangle. If more than two forces are coming into effect, then we can represent it using polygon, which is explained by polygon law of forces. So look at this figure. This one of the forces A, next force is B, then the resultant A is acting anti-clockwise, B is also acting anti-clockwise, then the resultant A plus B, which is the third side, which is acting clockwise. So look into this figure this triangle OBC. The one side is A plus B, the other side is C. These two are acting anti-clockwise. The third side OC, which is the resultant A plus B plus C, which is acting clockwise. Then considering OCD, A plus B plus C and D are the two adjacent sides which are acting anti-clockwise. Then the resultant A plus B plus C plus D is acting clockwise. Or we are considering as a whole, this polygon is, how many sides are there? 1, 2, 3, 4, 5. So this is a pentagon. So the fifth side, the closing side will be the resultant. So this side, OA, AB, BC, CD are the forces A, B, C, D. These are represented in anticlockwise direction. The closing side, which is the resultant OD, A plus B plus C plus D, which is acting in clockwise direction. So this is polygon law of forces. With this, we can conclude all the laws in engineering mechanics. Using all these laws like Newton's first law of motion, second law of motion, third law of motion, these combinedly we can call it as Newton's laws of motion. Newton's law of gravitation, transmissibility law of transmissibility, and parallelogram law of forces, triangle law of forces, polygon law of forces. Using all these introductory portions, we can explain the further chapters. We can do so many classifications. We can identify or understand other engineering mechanics applications. With this, I am concluding. See you again. Thank you.